Vijay, been with Imply for 3 years. And, before Imply, I was in Cloudera. It's been in the big data space for quite some time now. Yeah, nice to see all of you. So, how many are hearing about Druid for the first time? Ready?
드루이드 처음 들어보시는 분 계신가요?
Okay, 1 or 2 at least. Okay, that is good. So everybody else at least has heard of Druid. Okay.
네, 그리고 저희 이제 한국에서
안녕하세요.
엔지니어를 담당하고 계시는 이기훈 이사님이시고요. 통역을 잘하시기 때문에 수업도 할 겁니다. 네, 그래서 진행을 해주시고 혹시 뭐 중간에 궁금한 거나 뭐 이렇게 질문 있으시면 그냥 자유롭게 얘기하셔도 좋거든요. 그래서 너무 이제 이렇게 쑥스러워하지 마시고 이제 많이 적극적으로 참여를 해주세요. 감사합니다.
Okay. So, the people who are hearing about Druid for the first time, for all of us, Druid is a database for a modern analytical application. How is that different from when you thought of analytics in the past? So this is different because when you think of analytics, your mind turns to, okay, I take a Tableau, I have a dashboard, nice pictures, nice visualization. But that's not what modern analytical application is. Modern analytical applications are where you're trying to query a lot of data under high concurrency with very small query response times, and often trying to combine data that is streaming in with data that is already there in a batch. This is what a modern analytical application tries to do. And this is usually arises when there is an end user application. So you're opening up your data to your user who is looking at their usage. For example, if there's a telco, they're looking at, each customer is looking at their usage. Or the case we're discussing about as a feature store, speeding up model training. This also comes under an analytical application, again, because you're not looking at just a static dashboard which is refreshing every 1 hour. That was analytics which was done in the past. But today nobody wants to do that. Maybe there is some executive who's looking at a dashboard, but even executives just don't want to look at a dashboard because that doesn't give them any insight. To get additional insight, you need to do a lot more things, and that's what Druid is helping customers do, build a modern analytical application. Just keep that in mind, because when I say analytics, everybody thinks of dashboard, Tableau, BI, but that's not the world we're talking about. We're talking about a very different world where the concurrency, the latency, the scale of data, and the ability to combine real-time and historical, all three matter. And you are trying to have a conversation with your data. Not just look at it once a day or something like that. You're trying to have a conversation with your data, and that's what Druid was created to solve, not BI.
드루이드는 최신 어플리케이션, 최신 분석 어플리케이션을 지원하기 위해서 만들어져 있고요. 근데 최신 모던이라고 하는 어떤 그 분석이라고 이야기했었을 때 사람들마다 생각하는 게 달라서 저희가 규정하고 있는 거를 말씀드리면은 크게 한 3가지 정도입니다. 첫 번째, 데이터 양이 굉장히 클 것. 두 번째, 높은 동시성, 하이 컨시커런시. 그리고 세 번째, 그때 굉장히 빠른 응답 속도. 이 3가지 문제를 해결하기 위해서 드루이드는 만들어져 있는 데이터베이스이고요. 기존의 어떤 애널리틱이나 이런 이야기들을 했었을 때 뭐 1시간마다 정형화해가지고서 보는 어떤 대시보드나 이런 것들을 생각하실 수도 있지만 많은 얘기들을 추가해서 하겠습니다. 실제로 현재 많은 그 고객들이나 엔드 유저가 보고 싶은 거는 현재 일어나고 있는 어떤 것들을 실시간으로 보면서 이제 데이터하고 이야기를 하고 싶은 거죠. 그리고 그것을 통해 가지고서 뭐 이제 오래된 여러 가지 배치 데이터가 있으면서 실제 현재 벌어지고 있는 데이터가 이게 어떤 의미를 뜻하는지 실시간으로 분석하고 그 데이터에 대한 이해도를 높여가는 과정들을 하고 싶은 거고, 드루이드는 그런 문제를 해결하는 데에 초점이 맞춰져 있습니다.
So how many look at the Druid summit, the virtual summit that happened 10 days ago, something like that? Yeah. Anybody attended the virtual summit? No? Okay, a lot of good content. This content I presented there, but a lot of customers also presented. So Dungan Market also presented on that. So those that's all available. I think it should be still available as a recording. So please try to take a look. A lot of good content was presented in the summit. Okay, let us do this. Okay, so this is a full thing I presented. I don't know how much we can go through. We will do as much as possible today. So where does Druid fit in the machine learning pipeline, like broadly? Talk about what happens with exploratory data analytics. What about monitoring input and output for machine learning pipelines? And then model training. These three things we will look at. And then I will have one or two demos, actual notebooks, Jupyter notebooks where I train some simple models so that we can look at how Druid fits into it. This is what we will do. Okay, where does it fit? Okay, so broadly, Druid can do three things. So Druid cannot do any machine learning on its own. And today there is no predictive or any other machine learning capability within Druid. But Druid does three things, right? So you can use it in ED, exploratory data analytics, where you want to understand different dimensions, different time periods, correlations, how metrics behave at different aggregations, which is very important when you're training forecasting models, for example. I'll show you an example of that. Okay, so exploratory data analytics to understand what your data, how the data can be used for predictions. That's the first thing you can do with Druid. Then monitoring, all these are being done by customers today. It's not something new. Customers are already started doing, many of our customers are doing this. This monitoring models, it's an interesting scenario because there are tools that can actually monitor the model from a machine learning perspective, instrument the model, MLOps, things like that. We're not talking about that. This we're talking specifically with respect to the data, how the data that is coming in to your pipeline, are there any anomalies in that data, and the predictions that are coming out, do we see any anomalies? And so if you are, for example, doing fraud detection for your customer, then before something can be, if you call something a fraud and the customer rejects a transaction, then that's definitely a loss. So you have to be very sure that that's not an anomaly, right? So that you can do with Druid. And then of course, training the model. Because, with model training, you have a huge data lake typically. You may have petabytes of data. How do you get different time periods of data, for example, from that data lake? Because it's very difficult to do if you are querying from Hive, or even if you're just querying from object store. Just getting that multiple different time periods so that you can train your model better. All that's very difficult, and you can do all that with Druid very easily. And in different types of models basically require different sets of data points. You might read thousands of data points, each data point from a different time period or different aggregation levels. I will show you examples of all that. The point is that all this allows you to innovate faster on the machine learning side. This is the point of using Druid. This is what I've heard from customers, why use Druid in these scenarios, because you can use something like Spark or Flink, things like Hive. Yes, it is possible. They can all do most of these things from a technical perspective, but can you do it quickly so that you can innovate faster on the machine learning side? That's where Druid fits into the picture. Right, so.
네, 일단은 그 드루이드 서밋이라는 행사가 있었고요. 그거는 저희 버추얼로 온라인으로 진행돼서 들어보신 분도 있겠지만 온디맨드도 있으니까 나중에 기회 되시면 들어보시면 좋을 것 같아요. 거기도 인플라이뿐만 아니라 드루이드 사용자들, 대표적으로 넷플릭스 같은 데들이 이제 많은 세션들을 하셨고 기회 되면 꼭 들어보시면 좋을 것 같고요. 거기에서 이제 발표했던 내용들이고 이게 저희가 상상의 나래를 펼쳐서 한 것이 아니라 실제로 사용하는 케이스를 갖고서 이제 저희가 좀 데모를 만들어서 진행을 하고 있는 거고요. 드루이드가 왜 머신러닝 파이프라인에서 강점이 있냐라고 했었을 때 기본적으로 첫 번째 드루이드는 그 SQL 레벨에서 뭐 머신러닝을 제공하는 함수가 있다거나 그렇지는 않습니다. 드루이드는 자체적으로는 머신러닝을 하는 알고리즘이나 이런 기능들이 없고요. 다만 이 세 가지 기능이 있어서는 드루이드가 기능 역할을 좀 충분히 할 수 있다라고 생각을 하고 있습니다. 첫 번째로는 이제 데이터를 분석해서 탐색하는 건데 드루이드 워크숍을 들어보신 분들은 아시겠지만 다양한 디멘전이나 다양한 레벨의 이제 집계를 통해 가지고서 여러 가지 분석을 하는 데 있어서는 드루이드가 굉장히 빠르게 수행이 될 수 있다는 점이 첫 번째고, 두 번째로는 이제 모델에 들어가는 데이터의 이익과 그 결과에 대한 결과들을 빠르게 집계할 수 있다는 거거든요. 가령 예시로 들었던 게 그 어떤 고객의 카드 결제를 카드사가 그 이거를 이제 이상 탐지라고 탐지를 해가지고서 리젝을 했는데, 그러니까 차단을 했는데 그게 알고 보니 뭐 정상 거래였다 그러면은 사실은 그거는 굉장히 좀 잘못된 거죠. 되게 중요한 거니까. 그러니까 그런 부분들에 있어서는 굉장히 실시간으로 어떤 문제가 있는지 어떤 모델에 대해서는 많은 것들을 판단해야 되는데, 그런 것들을 이제 실시간으로 분석하는 데 있어서는 드루이드가 좀 큰 역할을 할 수 있다는 거. 그리고 세 번째로는 트레이닝 더 모델, 그러니까 모델을 만드는 데 있어가지고서 모델을 만드는데 여러 시점에 여러 가지 뭐 디멘전이나 여러 가지 이제 애플리케이션을 통해서 여러 개의 데이터 포인트들을 만든다 그러면 그런 부분에 있어서는 드루이드가 굉장히 빠르게 이런 것들을 이제 가속화할 수 있다는 점이 세 가지의 큰 강점입니다. 물론 뭐 요즘 이제 많이 생각하고 계신 스팍이라든지 아니 뭐 굉장히 전통적인 하이브라든지 아니 뭐 아파치 플링크라든지 이런 기능들을 통해 가지고서 어차피 하려고 하는 거는 대부분 다 이제 자체적인 머신러닝이 아닌 이상 프로세싱이나 딜리버리 관점에서 모두 다 가능하지만, 과연 이것들을 이제 대용량의 데이터에서 뭐 손쉽게 지속적으로 이제 빠르게 진행해가지고서 머신러닝 모델이 만들어지는 그 프로세스를 가속화할 수 있냐라고 얘기했었을 때는 실제로 이 드루이드를 피처 스토어 형태로 많이 사용하고 있는 고객들을 저희가 많이 보고 있습니다. 그런 것들은 이제 뒤에서 어떤 부분들이 좀 구체적인 강점이 있는지 이야기를 드릴 겁니다.
Okay, so some more examples of where Druid fits in. So if you think of exploratory data analytics, one of the things you want to do is you want to understand, how many of your data, how many of your rows have null values, right? And you want to filter out null values because machine learning models don't do well with null values. So filter operations are very fast in Druid, as we all know. Druid has got bitmap index, so very fast filter operations. If you're looking at row counts, right? So if you have skews in your data, and you want to look at how skewed your data is with different dimensions, you need to look at row counts, and that's also very fast because aggregations are very fast in Druid, right? So we all know this. I'm just giving an example of how Druid fits into this picture.
여러 데이터에서 널 밸류 같은 것들을 걸러가지고서 데이터 반란한다고 했었을 때도 드루이드가 굉장히 빠를 수 있고, 그 다음에 이렇게 데이터가 스큐가 돼 있으면은 각 카디널티별로 이제 어느 정도의 분포도를 갖고 있고, 그거에 따라서 데이터 분석에 들어갈 파이프라인을 어떻게 설계할지 같은 것들이 이제 고민이 되는데, 뭐 이건 일부의 예시지만 이런 부분들에 있어서는 드루이드가 픽트웰 리퀘스트도 있고 굉장히 빠르게 진행할 수 있다는 점이 큰 강점이라고 보시면 될 것 같습니다.
These are all things you do when you do EDA, right? So you want to understand mean, standard deviations, variance. If you're training a regression model, you want to understand all this for your metrics, because again, the idea is remove outliers. You suddenly have some data that is way outside your mean. That is like instead of 2 or 3 standard deviations, suddenly you see something that is 6 or 7 standard deviations outside your mean. Then that becomes an outlier. You don't want to use it in your training, right? So Druid can do statistics very well on petabytes of data, streaming, batch, everything. So we know that. I mean, many of us have experienced those who've used Druid. So again, this is a capability of Druid. Now, one of the things when you're doing forecasting, something like an ARIMA model, right? You are trying to forecast some metric, and when my data is in millisecond granularity, if the data is very noisy, I need to be able to aggregate to maybe 1 minute, to maybe 1 hour to reduce the noise so that my forecast is more accurate. Because if you're forecasting on noisy data, you end up overfitting and it won't work in the real world. So that's the time series queries. That's what you use in Druid to change your granularities. They're also very fast. And then you're looking at different time periods. So we all know that you have in your data, you'll have repeating patterns, weekly patterns, monthly patterns, quarterly patterns. you need all that pattern to be used in your training so that model can work effectively in the real world. Again, time series queries, very fast and true.
그래서 페타바이트 데이터에 대해서 어떤 그 통계 집계를 하는 것들이 굉장히 빠르게 드루이드에서 활용될 수 있다는 거하고, 뭐 아리마 같이 어떤 시계열에 대해서 데이터를 갖고서 이제 시점 부착을 한다든지 했었을 때에는 타임 시리즈 쿼리들은 기본적으로 드루이드가 시계열 데이터를 저장하기 위한 데이터베이스다 보니까 이 쿼리들이 굉장히 빠르게 나올 수 있다는 점. 그리고 아까 말씀드렸던 다양한 시점에 대해서 뭐 예를 들어서 월별 패턴이라든지 아니면 어떤 시즈널리티를 가져가가지고서 그거를 학습 파이프라인에 넣어야 되는 경우에 마찬가지로 타임 시리즈 데이터이기 때문에 그런 부분들을 처리하는 데는 드루이드가 굉장히 빠르다는 점이 큰 강점이라고 보시면 됩니다.
Okay, so that was EDA. Now monitoring models, you typically go with this kind of an approach where input to the model comes in, there's a machine learning pipeline which is doing the predictions, output goes, you bring both into Kafka and then ingest into Druid and then you can monitor it. Now, what does monitoring actually involve? Again, you're trying to identify miscalibrated models or anomalies in your input data. So some examples here, right? If you take this sequence, now what is an anomaly here? Now in general, if you think of this as a credit card transaction sequence, this 3 looks like an anomaly, but in credit card world, it is known that there's a credit card fraud only when there is a continuous sequence of higher value transactions. This 3 is probably not a fraud, although it may be an anomaly. Right, so to identify these kind of things in your data, in your predictions, if your model predicted a 3 as a fraud, and you know that it's not a fraud because it's not according to what you expect, you need to be able to look at different time periods, slice up by different time periods, compare different time periods. So that's also very easy to do in Druid, right? Comparing time periods very fast. So the idea is you need to find multiple needles in a haystack. So you're not looking at just one aspect of the data. You need to be able to look at different aspects. That's where Druid really helps. Okay.
그래서 아까 전 장표를 보시면 기억하시겠지만 모델이 있으면은 인풋이 있고 모델에 대해서 허용했다, 허용했다, 차단했다 하는 데이터도 드루이드로 받고 카카오를 통해서 그다음에 그 실제 인풋도 같이 이제 받으면서 실제로 이게 이상으로 기록이 되는데 이상이 아닌 것들 이런 것들은 이제 빠르게 이제 발라낼 수 있어야 된다는 거죠. 가령 뭐 이런 데이터들을 봤었을 때 그냥 이 숫자만 보고서 이상 탐지를 하게 되면 이 중간에 있는 3은 굉장히 이상 감지에 이제 걸리는 숫자인데 가령 이제 그 뭐 카드 결제 세상에 있어서는 봤었을 때는 오히려 동일한 카드가 반복 결제되는 것이 이상 그 프로드인 거지. 뭐 그 머신러닝 사이드에서는 이게 이상으로 분류될 수는 있지만 실제 비즈니스 레벨에서는 그게 이상 탐지돼야 되는 대상은 아닐 수 있는 거죠. 그래서 이런 부분들을 실시간으로 빠르게 찾아서 어떤 업무들에 이제 반영해가지고서 적절한 이제 값들을 찾아내는 데 있어서는 그런 실시간성 업무들이 실제 머신러닝 환경에서 지속적으로 이제 임프루브가 될 때는 꼭 필요하다는 겁니다.
So one thing to note in this kind of situation is this all has to happen in real time on streaming data with often millisecond query responses, because if you think of like for example Visa uses Druid to do exactly this, that if a transaction is fraud they reject it, but then if they reject a transaction they lose money, so they better be very sure that it is fraud, and the whole thing is happening not even in 1 second, right? Somebody swiping a credit card somewhere, and within that time it takes to finish that, they need to identify whether it's fraud or not and approve it or not approve. So the speed is very important in these kind of situations. You cannot wait for minutes even, right? So
실시간성.
okay. Model training, again, what does Druid bring to the table? Extract different data points from multiple time intervals. I think we already talked about that. Train models on different granularities and compare accuracy. I'll show you an example of that. And you can extract specific patterns and check your prediction accuracy. And this example here, one of the customers is using a genetic algorithm to predict what programs customers will watch on a streaming platform. Right? So they're using a genetic algorithm. So they need thousands of data points, because in a genetic algorithm each each data point is a gene, and it happens in a, I mean, then the evolution begins, and then the prediction and outcome of the evolution. That's how genetic algorithms work. So they need thousands of data points, and even if you think of taking 1 second per data point, that's too much. Right? So that's why they're using Druid. And just remember that all this needs to happen with lots of data scientists often querying it concurrently, right? So that they can try out different models and innovate on the modeling side. That's what the scenario we're looking at.
아까 데이터 포인트에 대해서 얘기를 드렸고, 그 다른 그레디언트에 대해서 예를 들어 시간별 데이터로 볼 거냐, 분별 데이터로 볼 거냐, 15분 데이터로 볼 거냐에 따라서 다른 정확도가 나오는 것들을 이제 비교해 볼 수도 있을 거고, 그 다음에 그 특정 기간에 대해서 어떤 패턴이 나오는지 이런 것들을 찾아낸다던가, 아니면 제네틱 알고리즘 같은 걸 쓰게 되면은 여러 데이터 포인트들을 쭉 만들어 가지고서 이제 그 뭐 CNN이나 RNN 같은 것들이 돌게 됐었을 때는 굉장히 많은 데이터 포인트를 넣고 알아서 이제 돌게 되는데, 그런데 활용되었을 때는 이제 드루이드가 빠르게 돌 수 있다 보니까 이제 이런 부분에 있어서는 많이 활용이 되고 있고요. 특히나 데이터 사이언티스트가 많은 조직이면 많은 조직일수록 동시성이 굉장히 많이 올라갈 거기 때문에, 특히 시스템에서 자동으로 이제 그 여러 가지 머신러닝이 돌고 있다 그러면, 그럴 때는 이제 드루이드가 강점이 있다 보니 많은 사용자들이 이제 드루이드를 활용하고 있는 걸 보실 수 있을 겁니다.
Okay, let's move to the demo. So this data set here is a clickstream data set. Okay, let's take a look. This is hosted Druid by Imply, Polaris. I won't go into what Polaris does, but just let's take a look at this. Before I go here, first of all, this is having a lot of data, right? So let's make sure that we understand how much data this thing has. Why am I having all this? Okay, sorry. Let me go quick, select. This has about 3 billion rows, which is what this data set is all about. So let's run this quickly. No, actually it's 1.3 billion rows. This is the amount of data that's sitting in this data lake, right? There's not a small amount of data, a reasonable amount of data sitting there. Now, what typically I want to do with clickstream data, right? If I go in here, let's look at this data set. So this, I'm going to remove all this. Let's take a look. I'm going to go ahead and get conversions. Okay, and then put the time in here. And change this to line chart. And then change this to a particular date, because I want that date just to show you what we do. Okay. So this chart here, it loads up. It shows the conversions from my clickstream. I'm measuring conversions, and I see that there was a drop in conversion. The question is, can I create a simple regression model to predict this? This is the basic scenario which I will try to address here. I don't think this requires translation so far. Okay.
이런 구독이 빠지는 시점을 이제 예측할 수 있냐 하는 게 이제 뭐 가장 이제 직관적으로 생각할 수 있는 문제겠죠.
Right. So I started creating a regression model here. So first of all, I connect to my this is PyDruid. Right? This Jupyter notebook is running PyDruid. With PyDruid, you can connect from Python to Druid from a notebook. That's what I'm doing. So I have some connection here. I won't go into that. So first is I'm running this query. So you can see this is a Druid SQL query. It's picking up a few things: unique session, unique subscription, and cumulative subscription. Now, why did I do that? Let's go here. So unique session, unique subscription. So if you see this particular section here, let's filter this. Okay, there is some, when the subscription drops, there is some pattern that is recognizable in both. So as a data scientist, I may think that yes, this can be used for prediction. So that's the first place where I start. So I went ahead and ran this query. I'm going to run this query live, there's no issue, it will run. Oh, but it run. Am I connected to the net? Oh yeah, it ran. So this is my Druid query that ran. So again, remember, I'm running this on that 1.3 billion data set in the lake. Then I create a data frame in Python here. It's directly writing the data into the data frame in Python. This is the data frame. It's got the unique section, unique subscription, cumulative subscription, number of clicks. and the time period. Right? That's what the data frame in Python is. Now, I'm doing a few operations to get the data frame in the format I need for predictions. These are things you would normally do in Python when you're doing modeling. Right? This is not something you would do in Druid anyway. So I'm going to go ahead and run this, do a few more things, and let me run this. Okay, so here I'm bringing in a k nearest neighbor regression model. This is one of the regression models available in the scikit-learn library, which is a pretty standard library data scientists use for basic machine learning model training. You could use TensorFlow or something like that, but this is simpler to demo. I didn't want to get into all that. Okay, so this is the model. I'm fitting it to the results of that query. And the model actually seems to work well. I have a mean square error of this, which is essentially 0.8% error. Right? 0.008184. That is 0.8% error, which is good. But I want to see whether it really predicts that drop. The drop is out here, right? Does it really predict that drop? That's what I want to see. Let's go back. This particular drop, does it really predict? So what I did was I narrowed down the time. In the next query I ran, you can see I narrowed down the time to where the drop happened, 03 to 04. So I'm going to run the query. So you can see how this is happening. I ran an earlier query in Druid. Now I changed the time frame. I'm running the query again. If without Druid, right, you'll have to bring all the data into Python and try to do all kinds of things with it, which will cause all kinds of problems. So query ran. Again, I'm training a model. Now again, let's check what it gives me. Now if I run it, it's giving an error of 4.2%. From 0.8 to 4.2% is the increase in error for that particular time period. Obviously my model is not good. But can I improve the model? Right. Yes. So again, go back. So this, what I'm doing here is essentially exploratory data analytics. I'm looking at something that happened in the past and trying to find metrics which I can use to predict by looking at whether the metrics are behaving in a different way when that event happens. And then I'm doing the predictions and see how good my model is. This is the process you would go through when you're doing model training. Do an exploratory analytics, find out metrics and dimensions you can use for your predictions, do the prediction, evaluate the model, go back, continue in that iterative process. This is what you normally do. Now I'm going to remove this measures here.
Yeah, let me
Okay,
just
right.
sure. 그 지금 하고 있는 거는 그냥 처음에는 조금 더 긴 기간에 대해서 뭐 그 머신러닝을 돌려봤고 결국에 머신러닝 프로세스라는 거는 결국에는 기대되는 거는 이 빠지는 구간을 이제 예측할 수 있냐라는 거고 거기에 이제 상관관계가 있다고 생각한 지표 두 가지를 이제 쿼리로 뽑아가지고서 좀 더 긴 기간에 대해서 데이터를 뽑아가지고 학습을 돌렸을 때 아까 정확도가 0.08 어떻게 나왔던 거고요. 그렇게 해가지고서 좀 긴 기간에 대해서 돌렸을 때는 그 이밸류에이션이 나쁘지 않게 나왔었는데 만약에 조금 더 기간을 줄여가지고서 3, 4일로 이제 학습을 돌렸더니 아까 보셨으면 기억하겠지만 0.4 얼마 정도가 나왔죠. 그러니까 모델이 별로 더 오히려 그 정확도가 떨어지는 거죠. 그래서 그런 이 시점에 대한 것들을 바꿔가면서 이제 모델을 이제 계속 보고 있는 거고요. 그리고 제가 무슨 말을 하려고 했더라? 네, 오케이. I mean, you can go on. 그래가지고서 이제 다양한 시점에 대해서 모델을 만들고 이제 그 성능을 확인해보고 있는 것들을 지금 하고 있다고 보시면 될 것 같습니다.
Okay, now I'm going to add different measures. Okay, I have some measures here. Add these. Add this guy. And add this guy. And these are intersections. So when the user comes to home, so one of the things in a clickstream data is users going through different states in your website, right? So they come to the home page, then they exit the session, home page to subscription, home page to content. So this is typical of a clickstream data set. User comes to different, parts of your website or your app, and you can identify. Now, if you see when this dip happens, there's obviously a pattern here. There's another pattern here which corresponds to that. So, and then here also there is some kind of pattern. Right? So this tells me that using these other metrics, I might get more accuracy in my model. And I go back to my notebook. and now I run this query, which is using this data sketch intersection from Druid to intersect users who came to those two pages or those two pages in my app or in my website. I'm using that now to do the model. So let's try that. So just imagine as I'm going through this without Druid how difficult this is going to be to do just in Python. Right? So it's going to be extraordinarily difficult to do this. You have to write lots of code to pull this off. Right? So again, fit the model, check its accuracy. Now the model accuracy is improved to 2.54 from 4.2% to 2.4%. So I've gained almost 100% gain in my model accuracy by changing the metrics using this SQL query. So which is what I was talking about earlier. With Druid, you can get arbitrarily different metrics from your data set and try out those to see which actually gets you a better model for that particular event. So this is the whole idea, and you can see this can be done very fast with Druid. Much more difficult to do. I mean, it's not impossible to do in Python. If you're a Python expert, I'm pretty sure you can figure out how to do all this in Python. But again, you have to get a lot of data into Python, or you have to store it in a file and write lots of Python code to do all this. But this is very, very straightforward to get at the data in Druid. Of course, you do the model training, everything in Python as always. But just to get the data, different types of data, different metrics, different time periods, that's what I was talking about earlier. This is a quick demo of how it improves your model accuracy.
그래서 아까 빠졌을 때 다른 데에서 특이한 패턴이 나타나는 지표들이 뭔지를 좀 먼저 찾은 거고요. 아까 화면에서 보셨을 때 특이한 패턴들이 좀 있었지 않습니까? 그리고 그 시점에 아까는 처음에는 이제 다른 유니크 세션이나 이런 것들을 이제 쉽게 얘기해서 그 독립 변수로 이제 생각을 하고 이제 모델을 돌려보고, 지금은 이제 그 위에다가 그 클릭 스트림이면 이제 어느 유입 경로가 스테이터스가 어디고 언제 나갔는지 이런 데이터들을 찾아가지고서 그 장애가 이 딥이 생겼던 이 구독이 확 빠졌던 시점에 특이한 패턴이 나타나는 거를 시각화로 먼저 찾아보고, 그 데이터들을 이제 땡겨 와가지고서 모델을 돌려가지고서 기존 모델 대비 이제 성능이 개선되고 이런 것들을 뭐 시각화적인 부분이나 아니면은 구현의 그 방법론에서 훨씬 더 앞당겨서 할 수 있다라는 거죠. 물론 뭐 아까 이야기한 것처럼 뭐 파이썬이건 아니면 다른 코드건 이런 것들을 코드 레벨로 할 수 있지만, 데이터 양이 첫 번째 적지 않고 그 다음에 이런 것들을 파이썬 코드로 구현한다 그랬을 때는 상당히 많은 부분들의 이제 작업 공수가 들어가는 부분들을 드루이드를 사용해 가지고서 많이 그 간소화할 수 있다는 것이 이제 첫 번째 데모의 일점입니다.
Okay, very little time. I'll just finish off with one last example, quick one. So in here, I'm actually training an ARIMA model to do predictions on some stock market data. Now, I won't actually do it right now, but just to point out a few things. This does a lot of things, correlations and all that. But the important point is this, right? So when I do the forecasting in here, where is that? Yeah. Okay. So first I ran the query with, you can see I'm running it with 1 day granularity. So I'm using Druid's SQL query to make that granularity 1 day. I trained an ARIMA model and it did not very well. This is the forecast. This blue line is actual data. It is not doing very well. Then I went and took 6 hours granularity. You can see PT 6 hours. Right, so now it is doing not great. So it's not working out very well. Then I went and took 1 hour granularity here. You can see that here. 1 hour granularity. And the model really works well. So it almost conforms to my forecast here. So this is, in forecasting, this is where Druid really shines very well, because you can store data at a millisecond in Druid and then keep aggregating or disaggregating depending on what you need in your ARIMA model. That's what this shows. Just a quick overview of what it does, but that's the usefulness of Druid in forecasting. And forecasting is used very much in anomaly detection. That's where this comes in.
그래서 쭉 보여드렸는데 이제 주가 예측하는 것들을 이제 보여드렸는데 주식 예측을 이 정도로 할 수 있다 그러면 저도 써야겠지만, 첫 번째로는 이 그래뉴리티를 하루 날짜로 해가지고서 봤었을 때 별로 성능이 그렇게 뭐 빨간색이 이제 예측된 결과고 파란색이 이제 실제 결과였다고 하는데 사루치를 그레이널티로 잡아가지고 사루치 단위로 갖고서 이제 모델을 돌렸을 때 이제 뭐 예측이 별로 정확하지도 않았고 6시간 단위로 돌렸을 때도 예측이 정확하지 않았는데 1시간 단위로 이제 돌렸을 때 이제 거의 예측이 상당히 정확하게 나오는 걸 볼 수 있다는 거죠. 그래서 아리마나 아니면 아이솔레이션 포레스트 같은 이런 그 시계열 데이터를 갖고서 이제 포캐스팅하는 예측을 하는 모델을 돌릴 때는 그 그래듈리티를 어떻게 단위를 가져가느냐가 모델 트레이닝에 굉장히 큰 영향을 줄 수가 있는데 드루이드가 갖고 있는 강점은 데이터 자체는 밀리세컨드 단위로 실제로 그 로레벨에서 저장을 하면서 원하는 여러 그래듈리티로 이제 시점 대비 이제 집계하거나 어떤 값들을 뽑아가지고서 머신러닝 파이프라인에 던져줄 수 있다는 거죠. 이것이 이제 시계열 데이터를 갖고서 어떤 프리딕션을 하는 데 있어가지고는 굉장히 큰 강점을 갖고 있다고 말씀을 드리고 싶습니다.
Cool, thanks. I think that more time, right? Too much.